Hello, and thank you for joining and visiting. What we're going to be covering today is my project overview and my submission for my AI product management course that I've taken in Coursera, offered by Duke University and held by John Reif Schneider. What we're going to be covering is the project overview here, and what we're going to be attempting to do is to build a model that can predict a combined cycle power plant output energy. The power plant has gas, steam, heat, and steam generator as energy that covers. And we have about 9,500 hours of energy reading from our sensors available. And what we're trying to predict is the net hourly electrical energy output from that power plant. What we have is a data set that we've downloaded, if you see here. And what we're going to be going through is how I built the model, step through, as well as evaluating the model. How I've laid out the notebook is layout with step information, step code, and step results. All right, let's get started. I will not execute a lot of the codes because it may take some time and I only have about 5 minutes. So please forgive. But if you do, I will post a link for you to run the code. What we're doing here is we're importing the libraries that we need as well as the data set we just discussed above and giving a little bit of layout of what the five rows look like in terms of the data. Step two, what we're doing is selecting the features. What we want to do is we want to understand the combine, meaning we need to understand all the features, all the variables in this instance are the temperatures, the vacuum, the ambient pressure, as well as the humidity. Those are factors of those are noted as X, and the Y is our target variable, which is the output that we expect. All right, what we're going to be doing is we're going to split the data here by 80/20 and then view the data a little bit in terms of our shapes. All right, we see the X shape here and the Y shapes here. All right, and then we're going to go through to the next step is really understanding how to build what models to choose and compare the models that we've selected through. I've chose four models to evaluate, which is linear regression, random forest, as well XGBoost and gradient boost. What we're going to be doing is we're going to evaluate the mean squared error metrics. What we want to do is understand the shortest distance between our prediction and the actual value that gives us the mean squared error. All right. Over here, what we're doing is we're initializing all the models and by the random state of 42. So we're reproducibility of 42. So it generates about random states of 42 as it runs the model. Um, what we've done is we've ran the model here. We've uh, we've done a cross validation of 10, meaning that it took 10 subsets and ran the model using those 10 subsets continuously to understand what the performance would look like. So here we have our results. For all the four models, we have our results. If you see linear regression, is the average difference was about of the mean was about 4.5. Here was about 3.4, and XGBoost tend to be the lowest, where it was 3.2, 3.21, but a little bit of a standard deviance of 1.9. All right. And then what we're going to be doing is going through step four on evaluating the model, on what we really think the model evaluation, how do we pick the best model? What we've done is we did through our previous comparison, we did believe that our regression model was our first one. And we're going through this model as we go through. I wanted to show you the results as I have a little bit of time left, and we have our regression models here. And if you see, this is where we wanted to pay attention to, is that the training set and our test set are very close, meaning what we trained our model on is very close to our the test set that came out of the the actuals. So what we have is our output here, plot, where we see our output. But to do another thing, what I've done is I've also I'd like to just go through this. I've also did residual calculations to understand if my plots were correct. So if you indicate this, my it seems majority of them um, landed with there, as well as I was able to put a data frame and do the difference comparison, understanding where if my plots were actually coming out to be as is. But thank you for your time.